Especially in science, which is why this is called scientific notation, you end up with numbers that are really long. And they're either very large, like 40 billion, or they're very small, like really long decimals, like 0.000000000043. You get really small decimals when you talk about like the weight of an atom. Right? Those are long decimals, but that makes them tiny, tiny numbers. But they're long. And nobody wants to write down, like this right here, 2.1 times 10 to the 14th would have 13 zeros. Nobody wants to write all that. And you especially don't want to do mathematical calculations with numbers that long. It's very complicated and difficult, and it's easy to make mistakes because you've got these big, giant strings of numbers.
Like a mole?
Like a mole, yeah. So they created scientific notation, and scientific notation is a shorthand for writing extremely long numbers in a short amount of space. They don't have more than 2 decimal places. So at most, you're writing 3 numbers here, an x, a 10, and some exponent. So the first step to go from standard form to scientific notation is that we're going to move the decimal Okay, so the first thing we do is we take the decimal wherever it is, and we move it until it is on the right of the first non-zero digit.
Forgot the dot for the 9.
Okay, that's the first step. The second step is that, well, we're going to do step 1 and step 2 at the same time. And the second step is that we count the number of places that we moved the decimal. Count has a U in it. This does not have 9 in it. Okay. If it is a large number, so we're talking greater than 1, not a decimal, then we're going to have a positive exponent. If it is a small number, so it's less than 1, so it's a decimal, we're going to have a negative exponent. This is the only time in math that negative exponents are acceptable. And the reason these are acceptable here is because this tells us big, long, giant number, billions and trillions and googolplex. The negative exponent tells us big, long decimal, so 0.000 for long zeros, and then some numbers at the end. And we also take out all the extra zeros. Because that's the whole point. Do scientific notation. This is not a terrible number, but it's long. Bless you. The decimal is here. We want to move the decimal to the right of the first number that's not 0. So this is the first non-zero number, 2. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8 places. absolute, or not absolute value, sorry, scientific notation, only want 2 decimal places. So that's going to be 2.01. Times 10. It's always times 10. And then this tells me my exponent. Okay. And it's positive because this was a large number, not a decimal. Here I have a decimal, so I'm going to move to the first number that's not a 0. So I'm going to put my decimal here, and that's 1, 2, 3, 4, 5, 6 places. So I'm going to be 5.1 because my decimal is now there.
Would that make it a -6 since it went to the right?
Yes, to the -6. And that -6 indicates that it was a decimal. Okay.
So you don't always have to write the hundreds place?
No. No, at most you want 2 decimal places. If there's not something here, if it was like a 3 here or something, then you'd write it. But if there's nothing there, you don't need to put something there. Okay. Move our decimal to here. So I'm going to go 3, 6, 9, 10 places. So 6.87 times 10 to the 10th. And then I'm going to actually, let's add some more numbers to this, just so I can show you what to do when there's too many numbers. Okay. Again, I'm going to move to the first number that I see that's not 0. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. But I only want 2 decimal places. So I'm not going to write 7.25675. That's long. We don't want it long. We're trying to make it short. So I only want 2 decimal places. That's here.
Rounded?
Yeah. This is going to round that 5 up. So it's going to be 7.26 times 10 to the -10th. So if there are more than 2 numbers where you should only have the 2 decimal places, you round. And if it's 5 or greater, you round up. And if it's 4 or less, you keep it the same. Hold on. How do I want to... Okay, the first way is the more kind of proper way. I'm going to write 6.32. And I have 10 to the 9th. And that's positive. That means I'm going to be moving my exponent or my decimal this way. So I'm going to go 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And for every blank space, I'm going to put a 0 in. So that means I'm going to have 632 0 0 0 0 0 0 0.
Yikes.
6,320,000,000. So that's method 1. Method 2 is hard to kind of write. But what I do is I'm going to go to the right, and I'm going to put down that first number, and then I'm going to start counting to 9. And the first 2 numbers I count to 9 I write down are 3, 2. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense? To the opposite direction. So with method 1, I would write down the 4, and here's my decimal, and I'm going to move 4 places backwards. So I go 1, 2, 3, 4, and then I put zeros in. So this is 0.0004. For method 2 or my method, I start counting again, except instead of moving this way, I start with, okay, if there was something after the 0, I'm going to change this a little bit just to give you an idea of what to do. I'm just going to add some decimal places. So I would write down the first two numbers, or the decimal, right? The 3, the 2. Then I start counting. Go 1, 2, 3, 4. Either way is correct.
Might as well be thorough.
So for method 1, I have the 3.21. So I'm going to move 16 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm going to put zeros in all of those empty spaces. So that's going to be 14 zeros, by the way.
14. I thought that's 16.
16 places, 14 zeros, because this is 2 of the places. Or for the second method, like I said, I just start counting. So I write down that first number and then I start counting to 16. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
That big.
So if you're multiplying, this is the other reason that scientific notation is so nice. Would you want to multiply 32 quadrillion 100 trillion times anything? No. Would be annoying, right? So you put it in scientific notation and then you're multiplying the decimals that are never longer than 2 digits each. Well, 3 digits total when you include the whole number part. And then you add the exponents. So to multiply these two numbers, this decimal basically times this whole number, I'm going to do 3.5 times 7. So I get 24.5. And then I add the exponents. -3 plus 5 is 2. Now, that's my new exponent. However, I am not allowed to have a number here greater than 10, or sorry, greater than 9. I can't have a 2-digit whole number part. So that's step 3, is adjust the decimal if necessary. Because it's always supposed to be one number, decimal place, and then 2 more places. So I need to move this one more space, and I'm moving here, so I'm adding here. So this will be 2.45 times 10 to the third. If you move the decimal to the left, like we did here, you add to the exponents. If you were to move the decimal to the right, then you would subtract exponents. So however many spaces you move, that's how many you add or subtract.
So in the case of that, since it's 24.5, if you moved it to make it 245, it would be
To the
10.
to the
just
1, yeah.
10 if you
Yeah,
moved
just
it like
10.
that.
At which point then you just write 2,450. Yeah. So, but yes, exactly. On this next example, we're going to multiply. So 6.5 times 8.7. I don't feel like doing it, so I'm going to cheat.
Lucky.
Mostly I just really didn't have room. And then my exponents are 12 plus negative 15, so that's negative 3. And so I have 56.55 times 10 to the negative 3. But I need to move this over 1.
Ooh.
And then I'm also going to have to round because I don't want more than 2 decimal places. So this 5 is going to round that 5 up. So it's going to be 5.66 times 10. I moved one place, so I add 1 decimal, or sorry, 1 exponent,
So it
so
would be
negative 2.
Mm.
So we'll multiply 1.95 times 7.8, and again, oh, thank you. And then I'll add my
X. Have to line up.
It's actually, there's a 0 here too, and it's the same 1, 2, 3, so it's 1, 2, 3. They don't line up, but they have the same number in multiplication. And then I have negative 8 plus negative 2 gives me negative 10. So I have 15.21 times 10 to the negative 10. And then I have to adjust this. Now you don't always have to adjust them, but it seems like in my examples they're all being adjusted.
Oh, I moved my decimal the wrong way.
So it would be like negative 9.
Yeah, so I add 1. So 10 to the negative 9. Now, just as an example, mostly when you multiply, you end up adjusting by moving to the left. It's when you divide that you usually end up adjusting by moving to the right, and we'll talk about that in just a second. Okay, this is the same. We're going to do dividing the decimals, then we subtract the exponents, and then we make adjustments if we need to. So first I'm going to do 3.066 divided by 7.3. That shouldn't even have that many decimal places, but so that's 0.42. And then for the second part, I'm going to subtract my exponents. So I've got 8 minus 3 is 5. So that's 10 to the 5th. But I'm going to move one place over to the right, so I'm going to subtract an exponent. So this is going to be 4.2 times 10 to the 4th. Divided 2.3958 divided by 1.98, I got 1.21. So the decimal was already in the right place. And then I did 3 minus 8, and I get negative 5. Sorry, that looks awful. So it's 1.21 to the negative 5, or times 10 to the negative 5, and I don't have to adjust this because it's already correct.
Where it needs to be.
So 1.305 over 1.45, if I do that division, I get 0.9, and then my exponent's 3 minus negative 4. 3 minus negative is happy guy, so it's positive, so it's 7. So times 10 to the 7th.
And it gets a +1, right?
But I'm going to move this way so I get a -1.
Moving to the right.
So it's 9 times 10 to the 6th. So if we move to the right, we subtract an exponent. Move to the left, you add 1. A polynomial is a generic term, and it can be any amount of monomials. So a polynomial can be a single monomial, or it can be 50 monomials, and they're connected together with addition and subtraction. So it's a sum of monomials, so it's connected with addition and subtraction.
Like, would it be like 1 plus 2? No.
So an example would be 2x to the 3rd plus 4xy minus 3y plus 2.
That's the 4 one you were.
Or just 6x. So a polynomial is a generic, poly technically means many. Typically when you're talking about a single monomial, you don't call it a polynomial, just call it a monomial, but it really is a polynomial. Sort of like when you're talking about a square, you call it a square, but it's also a rectangle. We just don't call it a rectangle, but it really is one.
Kind of like the group and then the subgroup.
Yeah. A binomial is a polynomial that has exactly two terms. Bi means two, like bicycle has two tires. So we have 2x plus 5, or x plus q squared. Just so long as it has two terms, and they could be subtraction, so maybe we'll make that x minus 2 squared, q squared.
Good luck solving that.
And a trinomial has exactly 3 terms. The most common ones you see are quadratics. Those are the most common, but any 3 terms.
What's a quadratic?
A quadratic has all of the same variable, and you have the
Usually
highest exponent is a 2.
Kind of like ends in a polynomial.
Is this a polynomial?
Yes.
Yes, it is a binomial. Is this a polynomial?
No.
Yes, it is a monomial.
Oh.
I just put bi and non.
Is this a polynomial? This is
Yes.
no.
No.
Binomial, I think.
See how this
Oh, the
knocks
fraction.
this down into the denominator? Remember I said that monomials don't have variables
no.
or in the denominators? So this is no because
Fraction.
it's a variable in the denominator. You can have fractions, you just can't have variables.
Like if the 3 was on the top one, then it would be okay? Or
If
no?
it was, yeah, if it was a to the 3 over 7, that's all right.
But it's not.
But it's not, yeah. So you just can't have variables in the denominator. You can have numbers in denominators, just not
It's
variables.
like trying to sneak in.
And is this a polynomial?
Yes.
Yes, what size?
Trinomial.
Right, try, because these go together.
1, 2, 3.
So yes, it's a trinomial.
But if it was supposed to be like that, that would be a poly.
Oh,
Yeah.
I see. It's a negative 3.
Okay, the degree of a monomial, they have degrees, and what you do is you add up the exponents in the monomial. So if I have 6x, let me do that in a different color so it shows up better. So if I have 6x squared, I have one variable, one exponent, so the degree is 2. If I have 4x to the 3rd, y to the 5th, my degree is 8.
Oh, I remember this.
Okay, so I'm
So-
adding the exponents. If I have 3 squared x squared, it's the variable exponents. So you don't count this 2 on the 3. The degree here would be 2 still. So you add up the exponents on the variables only. The degree of a polynomial, so if I have a polynomial, and let's say I have 4x squared y plus 3x to the 5th, y to the 3rd, plus 2y to the 9th, plus 4x to the 5th, y to the 10th.
Yikes.
How did you?
I'm just making it up off the top of my head. It's just stuff. Okay, so there's an invisible 1 every time there's no exponent, right? So this degree of this monomial is 2 plus 1, so that's 3. The degree of this monomial is 8. The degree of
9.
this monomial is 9, and the degree of this monomial is 15.
That looks
So
like
the
an 8 to me.
Polynomial degree is going to be 15, because 15 is the largest degree.
Just so you know, the 5 with the x at the end looks like an 8.
Okay, it's a 5. So you just, whenever you have a polynomial and you're asked to find the degree of the polynomial, you add the exponents on each individual term, and then whatever is the biggest number, that's the winner.
And if they're equal, then you just take that one?
Yeah. Yeah, if both of these, like let's say this one was also 15, then it would still be 15. Okay, if you have a number by itself, a constant like 4, the degree of this number is 0.
Not a 1?
No, because it's the exponent on the variable, and there is no variable,
Oh.
so it's
But
0.
if it had an A with
Then it would be a 1. Yeah. But if it's a number by itself, so this 6 by itself, its degree is 0. This 7 by itself, degree is 0, degree is 0.
So it's only the exponents on the variable.
It's only, now here I have 2 and 3, so this degree is 5. I've got 5 and 0, so obviously 5 won that. Here I have 3,
That's 4.
4, and 0, so my winner is 4. I have 2, 4,
More 4s.
4, and 0. I have 2 4s, but it's still the biggest number. So it beat out 2. So my degree is 4. No, camera, thank you. Okay, so the standard form is to put the polynomial in order from greatest to least degree. So all the monomials, so if we come back to this example back here, this one, on the degree of a polynomial, the 15 would come first. So 4x to the 5th, y to the 10th would come first.
So it would be 15, 9, 8, 5.
Yeah, plus 2y to the 9th, plus 3x to the 5th, y to the 3rd, plus 4x squared y. Because this is 15, 9, 8, 3. So you put them in order from greatest to least,
Based on?
the degree.
So for like example A, you would just move that 4, 5 to the front.
Now the leading coefficient is the coefficient, that's the number, right, on the leading term, which is the term with the largest degree.
So 4x to the 5th would be the largest.
Well, this is my leading term. 4x to the 5th, y to the 10th is my leading term, so my leading coefficient would be 4.
Oh,
The coefficient is just the number. If there's no number there,
it would be 1.
it would just be 1. So we put these in order. My degrees are 2, 5, and 1. So to put that in order, I'm going to list the 5 first, then the 2, then the 1. Here my degrees are 1, 0, 4, and 3. So I'm going to put the 4 first, and it's negative, and that's okay.
So it would be -2.
Yeah, the negative has to stay with the 2. Yeah, they stick together. And then on this last example, I have a 1, 3, 2, 6, and 0. So the 6 comes first. So -7y to the 6th plus 5y to the 3rd minus 2y squared plus y plus 10. Now the leading coefficient is then the first, once you've put them in order, the leading coefficient is just the first number you see. So the leading coefficient is 4, -2, -7. Method 1 is to leave it sideways.
And then I'm guessing method 2 is to go up and down.
So I have 2x squared
I prefer
plus
2.
5x minus 7 plus 3 minus 4x squared plus 6x. And all I do is I add together the like terms. So I have 2x squared and -4x squared. So 2 plus negative 4 is negative 2.
It's already been put in order if you, for the first half of it.
And then I do 5x plus 6x. 5 plus 6 is 11. And then that won't show up. Let's do purple.
Question, would it be right when you do method 2, like you put each one, you have to put into each other upside, like,
You have to line them up.
no, I mean, like, for example, if you take the 4x2 and you put it under the 2x2, although it's in the middle, when you're doing up and down.
Yeah, you
If
move
that's
them.
what I do,
You
it
have to
makes it-
rearrange them.
Yeah, it makes it easier.
Okay, so we're done. Method 2 is when you do up and down, so it looks more like traditional addition. So what we do is we write the
Addition.
first polynomial. I can't see that far. On top, and then the second one you write underneath, but you need to align the terms that are the same. So the negative 4x squared, the 6x, and the 3.
And
So 2x squared plus negative 4x squared is negative 2x squared. 5x plus 6x is 11x. Negative 7 plus 3 is negative 4. I'm just going to do this up here. So I'm going to rewrite method 2 to the side. So I'm going to put the larger one on top because that just makes more sense for me. Yeah. And then I have a y squared, a 3y, and a negative 5. So I just wrote that down because I'm going to start up here and I'm going to go, okay, 3y and negative 4y is negative y. And then y squared and 4y squared is 5y squared. And negative 5 and 8 is 3. And then I have this 2y to the third just sort of left over, so I write it down. And then I'm going to rearrange the order so that it looks pretty. And then I'll be done.
so the y going into the 4y, I'm guessing it's 5.
Or if I've rearranged them and I want to add them straight down, 8 minus 5 is 3, negative 4 plus 3 is negative 1, 4 plus 1 is 5,
And in other cases, you could also put
And
negative y.
2 plus nothing is 2.
You could make that a negative y too.
Yeah, and then I was going to rewrite it
That's
to make
just
it pretty.
nitpicking. That's not
Oh no, actually this is more correct.
We're not gonna fail.
1. I'm going to distribute the negative. So that changes all the signs, and this becomes 3 minus 2x plus 2x squared. That's the first one.
Isn't it supposed to be the other way around?
Minus 4x minus 5 plus 3x squared. So all of the signs in the second polynomial change. That's what subtraction does. Then I'm going to collect my like terms, 2x squared and 3x squared.
Wait, but you wrote down you're up and down the same way that we're.
Yeah. Shouldn't the negative, yeah.
Sorry. Okay.
Fixed.
2x squared minus 3x squared is negative x squared. Negative 2x minus 4x is negative 6x, and 3 plus 5 is 8. Okay. With method 2, we're going to write, I'm going to rearrange the first polynomial and go ahead and put it in proper order. And I'm going to change all these signs.
All of the ones on the bottom or all the ones on the
All the ones on the second polynomial. It always changes the signs of the polynomial being subtracted.
Okay, so, yeah.
Because if okay, hold, let me finish, please. Okay, if I were to write this, and then I wrote 3x squared plus 4x minus 5, which was, guys, which was the polynomial, and I just stuck that out front.
She's recording.
You have to be sure to do this. put the parentheses, because that minus has to be subtracting all, you have to make sure you go to everything. So that's why I wrote it as addition and changed the signs. Because
So you're really not adding,
you, there is, okay.